The future of transportation is on a roll as designers and engineers use tape for a growing number of demanding applications. Hi everybody, I'm Paul Trainer, and today we are talking about tape, also known as pressure-sensitive adhesive, or PSA. It is ideal for fastening and connecting various components and parts used in cars, trucks, boats, aircraft, and more. New applications for PSA tapes are being developed every day, and in many cases they are making traditional fasteners like bolts, screws, and rivets obsolete. PSA tapes offer a strong, durable bond that can withstand extreme temperatures and environments, helping you to join composites, plastics, and metal with ease. But it's not just about fastening. PSA tapes are truly multifunctional. They can dampen sound, reduce vibration, seal out moisture and air, and help keep corrosion at bay. PSAs can also reduce weight and improve the appearance and reliability of a product. And they improve productivity, saving you time, space, and money during manufacturing or assembly. So, how are PSA tapes used in transportation? Well, the graphics on this bus and the protective materials on these cars are pressure-sensitive adhesive tapes. In the hostile environment under the hood of a car or truck, PSA tapes are used to secure wire harnesses to the body of the vehicle and to wrap them under dashboards to resist squeaks and abrasion. It's tape holding the side panels of this horse trailer in place, reducing the weight as compared to a trailer that uses rivets while dampening noise and vibration as well. And tape is even used as a fire barrier in the cargo bays of ships and aircraft. The list of applications is a mile long. We're here at Element Materials Technology Lab in Detroit, Michigan, where they can put PSA tape through its paces. So, let's examine one application that we're all familiar with, body side molding. Why are so many designers and engineers choosing PSA tapes for this popular application? Well, for starters, PSA tapes can support a heavy load and can withstand repeated shock and impact. And since PSA tapes are applied across an entire surface, the stress is transferred more uniformly, reducing the maximum allowables needed. PSA tapes also provide a smooth, clean look with no visible fasteners. As you can see in these pictures, PSAs hold up a whole lot better than clips. PSA tapes are ideal for joining surfaces, but how do you quantify their properties to use them in a design? Well, we're here at the McCormick School of Engineering at Northwestern University, and we're going to find out. First, understand that PSA properties depend on achieving a good bond to both high and low energy surfaces. Tape reliability depends on selecting the right chemistry for your application environment and your usage loads. It's also important to consider that all plastics and PSAs are viscoelastic. The properties of polymers and adhesives are a function of two things: temperature and rate of deformation. So hot temperatures and a slow rate of deformation produce a viscous effect, whereas cold temperatures and a fast rate of deformation produce an elastic effect. Now, this rate dependency provides the key benefits of noise and sound dampening, durability, and conformability to complex surfaces and designs. Because of viscoelasticity, characterization tests for PSA tapes differ from traditional metal fasteners. Bolts are applied at discrete points, so the design constraints include the ultimate strength of the bolt, but also the stress concentrations formed at the holes in the adjoining parts. PSAs, on the other hand, are applied across an entire surface to form a continuous bond line, so the design constraints involve only the strength and durability of the adhesive. And remember, PSAs reduce noise and vibration as well. As with mechanical fasteners, there are several standardized tests for measuring the strength of a PSA: peel adhesion, dynamic and static shear, and probe tag. Carl, can you show us the peel adhesion test?
Sure thing.
Thanks. The peel adhesion test measures the force required to break the bond between the adhesive and the substrate. This test is similar to the ultimate tensile strength evaluated for a traditional metal fastener. The static shear test, which is similar to a creep test, provides a constant load to the PSA on a surface at a prescribed angle, with failure determined by excessive deformation. You can also measure tack, which is the ability of the adhesive to quickly adhere to the surface it contacts. The probe tack test measures the force required to pull a standardized probe at a specified rate from the adhesive surface. PSAs are inherently strong and durable. They're rated for extreme temperatures, and they continue to meet the lifetime design criteria of vehicle manufacturers. These cost-effective, multifunctional solutions have proven to be ideal for the transportation industry and for a variety of other industries as well. Now, we invite you to call on the Pressure Sensitive Tape Council for assistance the next time you have a unique design or engineering challenge. Just visit www.thinktape.org and click on Request for Information. Our experts will be glad to evaluate your product design and help you determine how pressure-sensitive adhesive can meet your needs. Think Tape, a bond you can trust.